All right, I'm going to show you the famous oil problem from 1989 AP tests, problem number 6. It says that oil is being pumped continuously from a certain oil well at a rate proportional to the amount of oil left in the well. Now, here they gave you, okay, here is the rate, dy dt, is proportional to the amount of oil left, which is y. So y is the amount of oil left in the well at any time t. Initially, there are 1 million gallons of oil in the well. 6 years later, there's 500,000 gallons of oil remaining, and it will no longer be profitable to pump oil when there are fewer than 50,000 gallons remaining. So first, we're supposed to write an equation for y, where y is the amount of oil remaining in the well at any time t. So we have our differential equation, dy dt equal to ky. So we'll need to separate the variables. Dy over y equals k dt, and we have to come up with the formula. So we'll integrate both sides. This becomes the ln of the absolute value of y equals kt plus c. We know that y is greater than 0 because it's an amount of oil. So we have then e to the kt plus c is equal to y, and y will equal e to the c, e to the kt. We know that initially y of 0 is 1 million gallons, so we put in 1 million for y, and equals e to the c times e to the 0, which is 1. So we know e to the c is 1 million, so my equation is y equals 1 million e to the kt. We know that there are 500,000 gallons of oil left when it says that it's 6 years later. So we know that when t is 6, we're going to get 500,000. So that'll be 1 million e to the 6k. So that becomes 1/2 equals e to the 6k. So 6k is going to equal the ln of 1/2. And k is 1/6 ln of 1/2. I can also write that as 1/6 ln of 2 to the negative 1, and then bring the negative around front, so it's negative 1/6 ln of 2. So you can choose, you can write it either way. If you don't want to write another fraction, you can do negative 1/6 ln of 2. So now we'll write our equation. It'll be y equals 1 million e to the negative 1/6 ln of 2 times t. And that's my answer for part A. Now, one little sidelight here. If you were taking an AP test, you do not have to do all of this work right here. For example, if you know, and you should know, that if you start with dy dt equals ky, you should know that it's going to end up with y equals y sub 0 times e to the kt. So for this problem here, you could have just started right off and gotten down to y equals, you know that 1 million was the initial amount, so that goes there, and you could have said 1 million e to the kt, and then from there, you could have plugged in the 500,000 here, and then your time 6 there, and you could have solved it. So you could start, basically, you could have started right here and then worked your way through it. All right. So now we're going to do part B. At what rate is the amount of oil in the well decreasing when there are 600,000 gallons of oil remaining? This can be a really tricky problem for a lot of people. But the sad thing is, it's unbelievably easy because you already know from back at the very beginning what dy dt equals. Dy dt equals k times y. You were told that. So dy dt is going to equal ky, and dy dt in this case, since k is negative 1/6 ln of 2, and we're supposed to find d by dt when what? When y is 600,000, so we put a 600,000 in for y, And we simply get out a calculator and we end up with negative 69314.718 gallons per year. So the amount of oil in the well is decreasing 69,314.78 gallons per year when Y is equal to when 600,000 gallons. When there's 600,000 gallons of oil in the tank, it's decreasing by that much each year. So now we go to part C, and part C wants us to find out at what time T should oil no longer be pumped from the well in order not to lose money. And it told you in the problem that it's no longer profitable when there's less than 50,000 gallons remaining. So we know it's not profitable when Y is less than or equal to 50,000. So we're going to set Y of T equal to 50,000 and find out how long it's going to take to get there. So I'm going to put 50,000 equal to the 1 million e to the negative 1/6 ln of 2 times t. Then that 50,000 over 1 million is 1/20 equals e to the negative 1/6 ln of 2 times t. So we know 1/6, negative 1/6 ln of 2 times t is going to equal the ln of 1/20. And so then t is going to be the ln of 1/20 over negative 1/6 ln of 2. And when you do that, you get 25.932 years. So that's how long you'll be able to pump oil out until it's no longer profitable.